How long would it take to fall through the Earth? Have you ever wondered how long it would take to fall through the Earth to get to the other side? And not by taking some special driller vehicle like in the movie The Core. We're talking about jumping into a hole that goes from one side of the Earth to the other. And while this entire experiment might sound like a waste of time, this scenario is often presented to introductory physics classes using a gravity tunnel model, which is a tube drilled from one side of the Earth to the other right through the center. The answer that's been taught for nearly a half century for how long the fall would take is an estimated 42 minutes and 12 seconds. But this answer has turned out to be wrong because previous calculations in the experiment assumed the planet was uniform. That was until someone by the name of Alexander Klotz, a graduate student in physics at McGill University in Montreal, Canada, predicted that an object should fall through Earth in 38 minutes and 11 seconds, instead of the 42 minutes and 12 seconds that was previously predicted. The difference is that his planetary reference model is based on seismic data. Speaking of seismic data, a lot of the data we have on the inner structure of the Earth comes from seismology, which is data collected from earthquakes traveling through the ground. Even if there was such a hole you could jump through to get to the other side of the planet, you might not be able to get there for a couple of reasons. In fact, you might be trapped in the hole forever after you jumped in, and we'll explain why. And yeah, we know that by this time you might be saying that it's impossible to drill through the center of the Earth. But it's not because the Earth is flat. We have scientific evidence of what our planetary structure and layers consist of. The inner core of our Earth is a round, hot, solid core of iron and nickel. Scientists believe that this core is spinning inside a liquid outer core faster than the Earth spins, which is 1,000 miles per hour. Besides the fact you can't put a hole through molten magma, there is no drilling through a solid spinning core of iron, but for our experiment, we're going to assume everything is solid and stationary. By the way, how do we know that the inner core is solid and the outer core is liquid? Back in 1963, a Danish seismologist named Inge Lehmann studied seismograms from earthquakes in New Zealand and could see the seismic waves were reflecting off the boundary of the inner core. The outer core was determined to be liquid from observations showing that compressional waves pass through it, but elastic shear waves do not, or very weakly. Shear waves are given this name because they move through the body of an object, unlike surface waves. But in order for something to fall through the planet, the object moving toward the center would have to increase steadily in density as it fell to the center of the Earth. That is because gravity doesn't remain constant the deeper inside the Earth you travel. In fact, the force of gravity would diminish to zero at the center of the core. When the distance to the center is halved, the density doubles and peaks to infinity at the center. Also, in order to get through the Earth, you or the object falling through would have to have the force of gravity remaining constant and equal to the value at the surface. You're probably asking why this is true, and the answer is because at the very center, the gravitational force would be zero because there's equal mass pulling at the center from all sides, and it would all basically cancel itself out. So, now that we have some science under our belt, the next thing is to take a closer look at what we are jumping through. As you jumped through the Earth, you'd pass all these different layers. The outer layer of the Earth, which is called the crust or lithosphere, is about 10 miles thick. It is composed mostly of granite, basalt rock, and loose material. The crust under the continents is 3 times thicker than the crust underneath the oceans. The next layer you would reach is called the mantle. It has a depth of 1,800 miles and is made of a thick, solid rock substance that equals 85% of the total mass of Earth. Speaking of mass, the Earth weighs about 1,000 trillion metric tons. The first 50 miles of the mantle is very hard and rigid rock. After that, approximately 150 miles deeper, you would encounter superheated rock. After that, you would go through more very solid and hard rock. The next phase of your fall would take you through the outer core, which extends to a depth of about 3,000 miles beneath the surface. But you better have protection against intense heat and fire because the outer core has a temperature of 4,940 to 7,640 degrees Fahrenheit. It is believed that this core is made up of superheated iron and nickel molten lava. If somehow you survived being incinerated at this point, you would reach the Earth's inner core. The inner core extends another 900 miles towards the center of the Earth. The diameter of the inner core is estimated to be 760 miles thick and is growing by 1 millimeter per year. To give you a better idea of its size, it's about 70% of our moon's diameter. It is very hot with a temperature of 5,400 degrees Celsius, 9,800 degrees Fahrenheit. It's important to point out that while the temperature of the inner core is hotter than the outer core, the pressure is so great on the inner core that the melting temperature of iron actually increases. There are two different possible outcomes of what would happen while making this trip. If you jumped in at your current weight without any change in your mass or density while falling, and without assuming constant gravity, you could end up like a ping pong ball going back and forth because of the gravitational waves. And since we have a hole dug straight through the earth with nothing to stop us, you could end up falling back and forth over and over. Remember when we said you might get stuck inside the hole forever? After some time, you would likely be stuck at the center because gravity would be pulling you in all directions as we previously mentioned. However, this is not taking into consideration the terminal velocity that you would reach as you jumped into the hole and started falling towards the core. As you fall, your speed would keep increasing, but only at the beginning of your jump than as you approach the center because the amount of gravitational force pulling on you is decreasing. When you reach the center, your speed is not increasing at all, but you would still be moving very fast. You'll be moving at almost 200 kilometers per hour. So with this taken into consideration, you wouldn't get stuck at the center, but instead shoot past it while making your way to the surface again. You would at some point zero out in speed as you reach the surface. But if you didn't jump out of the hole at that point, gravity would take over and start pulling you in the opposite direction again. However, the distance of the free fall would continue decreasing with each fall as you passed the inner core until it eventually stops you completely, just like a pendulum that eventually loses its speed and momentum. While this is a fun experiment to think about, we haven't been able to dig a hole deeper than the Kola Super Deep borehole in Russia, which is 12 kilometers deep. Even at the bottom of this hole, we are only 0.3% closer to the core than at the surface. Also, the high temperatures would burn anything to a crisp, and most of us would probably pass out as a result of claustrophobia and oxygen deprivation within minutes of jumping in. However, a fun thought experiment is always worth looking at, and we hope you enjoyed this one.